Hi, my name is Dai Matsuzaka, and today we're going to be covering Chapter 4.6, Linear and Quadratic Systems. So, the process of finding a solution to a system of linear and quadratic systems are as follows. You isolate for y using the linear equation, you substitute it into the quadratic, you solve the quadratic, and then substitute x into either equation to find y. So you're using the substitution method that you learned in the linear systems. Now, just to quickly show you what it should look like, the system would look something adjacent to this, right? And basically, you're just trying to find the pair xy such that both of these are satisfied at the same time. So let's just look at examples. So define the system of equations as follows, right? Y minus x is equal to 0, y is equal to x squared plus 3x plus 1. Well, let's do it. So y minus x is equal to 0 can be rewritten as y is equal to x. That's great. So let's just put this into the other equation, substitution. Then you get x is equal to x squared plus 3x plus 1. So then you get 0 is equal to x squared plus 2x plus 1. And there you go, our favorite example, right? So now 0 is equal to x plus 1 squared, which means that x must be equal to negative 1. And then what's y? Well, y also is negative 1 because we need to satisfy this condition. So there you go, very quick. You just substitute, figure out the quadratic equation, solve that, substitute back, and get both values. And you're basically done. Now, you do want to be careful because it is a quadratic equation that you're solving. And if you know anything about quadratic equations, you might get more than one answer. In fact, you might get two. So if that's the case, then you want to make sure that both of them are valid. And we're going to look at when that is going to be the case. So, if the graph of the line and the quadratic line cross twice, it has two solutions. If it crosses once, it's 1. If it does not cross, it has 0 solutions. And let's look at the cases. So here we have a quadratic equation. So let's just call this quadratic q of x. Let's call this linear, so p of x, right? So this system of equations will not yield a result. So even for substitution and whatnot, you just won't get a value that is valid, which you have some experience working with the linear system of equations. This is very similar to when we had two lines that were parallel to each other. You know how they never crossed, so there was no solution, right? This is the exact same idea. They don't cross, so there is no xy pair such that they satisfy the equations at the same time. How about this one? Well, this one satisfies the both conditions at this point at 0, 0. So if it crosses at one point, what does it tell us? Well, it just tells us that there's one possible solution only. That's it. And likewise, this is like when we have the cross with the lines in the linear systems of equations that we did before, right? There's one point in which it crosses. So there you go. You have it. And now this is a special thing that we don't actually have with linear systems. What we do with the quadratic is two potential points that satisfy the conditions for both equations, right? We have this initial intersection and this next intersection. This comes from the solving of the quadratic equation. You're solving for it, so then you're going to get two answers, right? You can get two answers if your discriminant is positive and it's not if it's positive. So that is a case in which you're just gonna have two solutions, and you need to have the two solutions because that's your full solution to your system of equations. So be careful, watch out, but this should not be very difficult to do if you know how to do quadratic equations very well. Again, I will refer back to the very first slide. I reiterate, all you're doing is you're isolating for y in the linear equation, as you have done here, right? Y minus x is equal to 0. So isolate y is equal to x. Then what do? You substitute the y into the quadratic equation, right? To get rid of the y. Then you get some equation that is equal to some polynomial with the x's equals 0. Then you just solve for the quadratic. You factorize it. And then what do? Well, you get the answer. You get x. And then with that x, you find y. Now, if you recall anything about the quadratic equation, sometimes the quadratic equation set to 0 will yield the result. Sometimes it won't. Now, that's where you have to be careful, and these visualizations should help you a little bit in working with those cases. Perfect. I'll see you in the next chapter.